Hello everyone, hope you all are doing good. Today we are going to discuss about the different engines which is basically used on the aircraft. Before we start, if you are new in this channel, subscribe our channel and hit the bell button to get our latest video. First question may arise in your mind is what is jet engine and how it works? You may have wondered how a jet engine works but gave up on the idea that you would be able to understand rocket science. But it's actually a simple concept to grasp and one that will impress the person by your side on your next flight. So, we are going to explain the processes involved so that anyone could get a good understanding of the underlying principles behind jet engines. So basically, typical jet engine consists of fan, compressor, combustion chamber, turbine, exhaust. Here is the overview. HPC stands for high pressure compressor, LPC stands for low pressure compressor, HPT stands for high pressure turbine, and LPT stands for low pressure turbine. Let's know about each part in detail. The fan is the first component in a turbofan. The large spinning fan sucks in large quantities of air. Most blades of the fan are made of titanium. It then speeds this air up and splits it into two parts. One part continues through the core, or center of the engine, where it is acted upon by the other engine components. The second part bypasses the core of the engine. It goes through a duct that surrounds the core to the back of the engine where it produces much of the force that propels the airplane forward. This cooler air helps to quiet the engine as well as adding thrust to the engine. The compressor is the first component in the engine core. The compressor is made up of fans with many blades and attached to a shaft. The compressor squeezes the air that enters it into progressively smaller areas, resulting in an increase in the air pressure. This results in an increase in the energy potential of the air. The squashed air is forced into the combustion chamber. In the combustor, the air is mixed with fuel and then ignited. There are as many as 20 nozzles to spray fuel into the airstream. The mixture of air and fuel catches fire. This provides a high temperature, high energy airflow. The fuel burns with the oxygen in the compressed air, producing hot expanding gases. The inside of the combustor is often made of ceramic materials to provide a heat-resistant chamber. The heat can reach 2700 degrees. The high-energy airflow coming out of the combustor goes into the turbine, causing the turbine blades to rotate. The turbines are linked by a shaft to turn the blades in the compressor and to spin the intake fan at the front. This rotation takes some energy from the high-energy flow that is used to drive the fan and the compressor. The gases produced in the combustion chamber move through the turbine and spin its blades. The turbines of the jet spin around thousands of times. They are fixed on shafts which have several sets of ball bearing in between them. The nozzle is the exhaust duct of the engine. This is the engine part which actually produces the thrust for the plane. The energy depleted airflow that passed the turbine, in addition to the colder air that bypassed the engine core, produces a force when exiting the nozzle that acts to propel the engine, and therefore the airplane, forward. The combination of the hot air and cold air are expelled and produce an exhaust, which causes a forward thrust. The nozzle may be preceded by a mixer, which combines the high temperature air coming from the engine core with the lower temperature air that was bypassed in the fan. The mixer helps to make the engine quieter. Let's have a look on how it works. All jet engines, which are also called gas turbines, work on the same principle. The engine sucks air in at the front with a fan. A compressor raises the pressure of the air. The compressor is made with many blades attached to a shaft. The blades spin at high speed and compress or squeeze the air. The compressed air is then sprayed with fuel and an electric spark lights the mixture. The burning gases expand and blast out through the nozzle at the back of the engine. As the jets of gas shoot backward, the engine and the aircraft are thrust forward. As the hot air is going to the nozzle, it passes through another group of blades called the turbine. The turbine is attached to the same shaft as the compressor. Spinning the turbine causes the compressor to spin. Hope you all have understood about the working of jet engine. Now let's discuss of its types. Today we will discuss about 5 main engines which is used on the aircrafts: turbofan, turboprop, turboshaft, turbojet and ramjet. Let's discuss one by one. This is the turbofan engine. Turbofan engines are equipped with a massive fan at the front for sucking in air. For turbofan jet engines, most of the air flow around the exterior of an aircraft engine to give the plane more thrust even at low speeds and make it quiet. Turbofan jet engines are powering most of today's airliners. All the air that enters the intake of a turbofan jet engine flows through the generator that produces the hot air. This generator comprises of a turbine, combustion chamber, and compressor. Only a small percentage of the air that passes through the turbofan engine reaches all the way to the combustion chamber. The rest of the air passes through a low-pressure compressor or fan, after when it is mixed with the produced gas are ejected directly. The objective of this system is to help achieve a higher thrust while maintaining the same level of consumption. The turbofan jet engine cut back the velocity within the same level of power supply and increases the flow of the total air mass to achieve this. The turbofan aircraft engine is an upgraded version of turboprop and turbojet engines. It works the same as a turbojet engine, but it has a ducted fan in its front. The fan cools the engine, creates additional thrust, and lowers the noise of the aircraft engine. The inlet air of turbofan engines is separated into two streams. One stream flows through the core of the engine while the other bypass air and flows around the engine. The air that bypasses flows through the engine, where a duct fan accelerates it to produce additional thrust. The ducted fan keeps pushing the air through the engine, which then continues to increase thrust. Turbofan aircraft engines are quieter than turbojets and fuel efficient. Their design also looks incredible. However, these engines are inefficient at high altitudes, and their frontal area is larger than turbojets, which makes them a little heavy. Turbofan aircraft engines are fitted with a duct at the rear of the engine. An independent turbine attached to the front of the compressor usually drives the turbine at the same speed as the compressor. The air from the fan does not mix with the engine air, but it can be ducted back to mix with the air at the front of the engine. The exhaust gas produces less than 25% of the total thrust, while 75% comes from the attached fans. This was all about turbofan engine. Now let's see characteristics of turbofan engine. Higher thrust, quieter than turbojet and fuel efficient. Inefficient at high altitude. Short takeoff ground clearances are less than turboprop but not as good as turbojet. TSFC, thrust specific fuel consumption, and specific weight fall between turbojet and turboprop. The turbofan is superior to the turbojet in hot day performance. A turbojet engine is a gas turbine engine that works by compressing air with an inlet and a compressor, axial, centrifugal, or both, mixing fuel with the compressed air, burning the mixture in the combustor, and then passing the hot, high-pressure air through a turbine and a nozzle. The compressor is powered by the turbine, which extracts energy from the expanding gas passing through it. The engine converts internal energy in the fuel to kinetic energy in the exhaust, producing thrust. All the air ingested by the inlet is passed through the compressor, combustor, and turbine. Characteristics of turbojet: low thrust at low forward speeds, relatively high TSFC at low altitudes and airspeeds, a disadvantage that decreases as altitude and airspeed increase, long takeoff roll, small frontal area resulting in low drag and reduced ground clearance problems, lightest specific weight, weight per pound of thrust produced, ability to take advantage of high ram pressure ratios. Now let's see about turboprop. A modern plane with a propeller typically uses a turboprop engine. It's similar to the turboshaft in a helicopter, but instead of powering an overhead rotor, the turbine inside it spins a propeller mounted on the front that pushes the plane forward. Unlike a turboshaft, a turboprop does produce some forward thrust from its exhaust gas, but the majority of the thrust comes from the propeller. Since propeller-driven planes fly more slowly, they waste less energy fighting drag, air resistance, and that makes them very efficient for use in workhorse cargo planes and other small, light aircraft. However, propellers themselves create a lot of air resistance, which is one reason why turbofans were developed. Let's see few characteristics of turboprop: high propulsive efficiency at low airspeed, low thrust at high airspeed, more complicated design and heavier weight than a turbojet, lowest TSFC. Large frontal area of propeller and engine combination that necessitates longer landing gears for low-wing airplanes but does not necessarily increase parasitic drag. Possibility of efficient reverse thrust. You might not think helicopters are driven by jet engines. They have those huge rotors on top doing all the work, but you'd be wrong. The rotors are powered by one or two gas turbine engines called turboshafts. A turboshaft is very different from a turbojet because the exhaust gas produces relatively little thrust. Instead, the turbine in a turbojet captures most of the power and the drive shaft running through it turns a transmission and one or more gearboxes that spin the rotors. Apart from helicopters, you'll also find turboshaft engines in trains, tanks, and boats. Gas turbine engines mounted in things like power plants are also turboshafts. Characteristics of turboshaft. Turboshaft engines are a little smaller than piston engines and have a higher weight ratio compared to piston engines. The only downside of these engines is that their gear systems are complex and break down easily. Ramjet are the lightest types of engines in aircraft and come with no moving components. The speed of an aircraft is responsible for forcing air into the engine. Ramjet operates the same as a turbojet, except that the rotating parts are not present. However, the fact that the compression ratio depends on the speed of an aircraft restricts the application of ramjet engines. Unlike other engines, the ramjet does not develop static thrust. Instead, it generates little thrust below the speed of the sound. That means an aircraft running on a ramjet engine requires assistance when taking off, which could be in the form of another aircraft. The ramjet engine has been used in space vehicles and several guided missile systems. Characteristics of ramjet: it allows the vehicle to achieve greater speeds with higher efficiency. They do not have rotating or moving parts.